Welcome to Spacecast. I'm Josh, and I'm here today with Bob Hall. Bob is the director of the ComSpOC, the Commercial Space Operations Center, as a global network of sensors, and they look at stuff in the sky and they create their own catalog, and Bob runs all those operations. So welcome, Bob.
Thank you, Josh.
And you prepared some slides and some videos and things that we're going to take a look at. So it's going to be a little bit different format from today because we're going to be looking at the screen quite a bit. And you notice that Bob and I are sans headphones today. It's just the way we're doing it. See how it works out. Make sure that not sure our audio is getting picked up. It looks like it is, so I think we're okay. Bob, before you get started on talking about some of these satellites, we've said you've been here before. You've been in the space industry for quite a long time, and you've seen a lot of stuff. And one of the interesting highlights of your career was back when the Russian space station, the Mir, was going to deorbit. You actually worked over in Moscow with Russia and for AGI and CNN. And what can you tell us about that story and what it was like? That was kind of a fun story. I don't think you can get into all the details that happened, though.
Right. That was with AGI, and that was. It was a whole lead up to that. There's a long history with the Mir space station, and at that time in 2001, the International Space Station was just getting started. There were a couple of modules that had been built, and that was clearly the wave of the future, and Russia was not going to be able to sustain both. Yet there were decades of national pride represented in the Mir, even though it had all kinds of problems. And so even though it was the right thing to get rid of it, it was still a matter of great pride to them. And so it was a delicate situation. But through the course of several months, we established contacts with them. There was a lot of churn in the world, in the media doesn't know a lot about space a lot of times. And Skylab had happened in the late 70s, and then now Mir is so much bigger. Yeah. And Mir is so much bigger. Is it going to come down? And the Russians took a little bit of black eye. But again, there had been some incidents with the Mir, accidents and what have you. So the press was sometimes not fully aware of the difficulties and was saying, well, geez, are they going to be able to deorbit this thing successfully? So our initial approach was to help them with some sort of technical visualization to demonstrate to the world what they were doing and how it was safe and how it was going to be successful. And that was the foundation of why we went, and it evolved into more than that. So we, unfortunately, or fortunately, the way our software works, we were using SDK at the time. SDK, a lot of times AGI, we make movies and we use them in marketing and we do this, we do that, the other thing. But SDK doesn't let you lie very well. SDK needs no kidding data. You can't do like what a graphic artist wants to do.
Right.
You need no kidding orbital data, attitude data, and it may not be a real satellite, but you need real orbital data, for example. And so if we were going to show this thing, we needed the exact plans. We needed the orbit, we needed the burns, we needed the thrust values, all that. And so we modeled the whole deorbit sequence using our maneuver trajectory tool, Astrogator. And so there were 3 of us over there during that final week. And during the deorbit, we were modeling the burns, getting the orbit updates, replanning the burns. And it was interesting. They were flying the mission, but they would come out every hour or so and check what our software had. It was kind of like an unofficial cross-check. Mm-hmm. And it was quite interesting. Like I said, we were the only Americans there, to my knowledge. It was myself and one other engineer, Frank Snyder, and then our CEO, Paul Graziani. The 3 of us were there for that week.
That's pretty fun. Sorry I was not able to make it with you.
Yeah. And actually another story, that part of that is we had another guy, Hank Grabowski, was on air live at CNN for that. And what happened is we had built a spectacular animation, again, based with SDK and knowing what we knew, and he was running it in real time at Atlanta at CNN headquarters. But he had a monitor down by his leg, and there was someone here at AGI headquarters. So we would have a chat from Moscow to AGI headquarters with whatever information we were able to release that was relevant to the scenario. Mm-hmm. And John Carrico, who's been on these before, was here relaying the salient points to Hank in a way that would help him describe what was going on.
That's pretty fun. That's exciting. And I think Hank was the one that made the call when they said, "Is it in?" And he goes, "Yes, it's in." And that was the official word, which is pretty funny. So today you're going to talk about some stuff that you've seen in the Commercial Space Operations Center, the ComSpOC, and some of the satellites you've been watching. Which one do you want to do first? We're going to do a couple of these and break them up so that you can get the report on just that satellite individually. Which one did you want to do first?
I think we'll start with Luch Olymp. That's the animation I have.
Getting back to Russia?
Scrolling in the background. So if you see here the animation, the yellow line is the Luch orbit, and the blue line is, at this point, it's an Intelsat satellite. Mm-hmm. Those orbits are being drawn with respect to the Earth. So these guys are in GEO. They're going around the globe. But instead of drawing a big circle, which doesn't look like you wouldn't be able to tell much, this is, again, with respect to the surface of the Earth, where it's moving, you can see the period. Mm-hmm. And so you see it's parked kind of close to the other guy. And I've got the number up there. It's 50 some odd kilometers away. So it's not going to necessarily bump into it. It's just weird. So weird
and
because
50 kilometers at GEO is not cause for alarm, but it is relatively close for plan purposes, right? I mean,
right. So with that, let's. I want to jump a little bit into what we know about.
He's got charts.
What we know about Luch, because I want to explain what we just saw, and like I said, right now it's Intelsat, but wait a week and it'll be somebody else.
Sure.
They're an equal opportunity offender. So first thing is, you notice I call it Luch Olymp. If you look in the catalog of objects, there's a constellation called Luch, which is a communications satellite, a relay satellite for Russia. When this was getting ready to be launched, they called this one Luch, but it was sort of a sleight of hand. This really isn't part of that relay constellation. This is the only one that's Luch Olymp. It's its own thing. Like I said, it was launched just about 5 years ago. Now, if you go out on the web, you'll see a lot of references that this is a SIGINT mission. So it's a high-interest object to us. We watch it as it does its thing. There's a little snippet of a web page right after it was launched. The Proton, from time to time has issues, and then they return to flight. So, as I said, this has parked next to over a dozen commercial communication satellites of all different companies. In almost every case, it parks about 1/10 of a degree away. Could be 0.5 degrees away. But generally at GEO, the boxes or the assigned slots for satellites are about 0.5-ish apart. So it's staying in like an adjacent box, sort of.
1/10 of a degree is how many kilometers?
1/10 of a degree is probably about 73 kilometers or so at GEO. So it sits there, and it, to our knowledge and our analysis, it hasn't shown any signs of attempting to rendezvous with the communication satellite. But what it is doing, if you do the analysis and look at it, is they appear to be parking close enough to be within the uplink beam for the ground stations talking to the communication satellite. Mm-hmm. And I'm going to show you a picture the next time. And it has stayed next to one of these guys from as long as 9 months to a few weeks. It varies.
So every guy that he goes and rendezvous with from a distance is a communication satellite?
Yes.
Well, as most satellites at GEO are.
Right. Excuse me. So, hang on a second. Sorry about that.
No worries.
So this is what I wanted to show you. So here we have an example satellite, and I've got a target satellite in blue, and I've got Luch in red. So this is where they are. This box represents where the target satellite lives, so to speak. And what I'm showing you here is how the uplink beam spreads from either the operator's ground station that controls the thing, that's this sort of yellowish one here, a small terminal, so these guys will have a small dish that talks to their comm satellite, their user terminals, and how it spreads out, or what I call a medium terminal. Now I believe these were for C-band. So for a typical C-band comm satellite, these are approximately how the beams spread out. And what I'm showing you here is the half power cutoff. So imagine the signal, there's no magical, you're in the beam and then there's nothing. It kind of gradually fades. But I'm showing you the half power. And comm engineers a lot of times will use that as a way to represent how good the signal is going to be. And the point here is that they are sitting right about on the edge of the half-power footprint for medium terminals and even the ground station. So they're not close enough. They're not going to crash into it or rendezvous with it because it doesn't appear to be a rendezvous mission. But yet 13 times they've done this sort of thing where they're close enough to sit in the uplink beam. The only reason for that would be if you were trying to listen to the uplink to that other guy. And like I said, they have changed who they're next to over the years. So let's look at that.
How big is the box that you have in that picture? Go back one sec. That box that you have there, the square in the middle representing the box that satellite is supposed to be in.
This is about 73 kilometers side to side.
So that's about the distance that you were talking about.
Yeah. And in this case, they're at this instant in time, these guys are probably about 80 kilometers apart. And like when I said the other guy's 50, that's how close they get. But not generally, 10 or single-digit kilometers.
Right, not a collision risk.
Right. Now, there have been times when they do a pair of maneuvers as a planned two-burn sequence. So they do burn one, and if something were to happen such that they were unable to execute burn 2 12 hours later, they might be on a path that puts them in a conjunction path. But generally, that's not the way they've operated. So here we have, over basically the entire mission, the longitude of Luch. So on the x-axis here is time. You see the calendar years. And on the y-axis is longitude.
Does that start in 2015?
It starts in late 2014 when it was launched. And this is longitude on the y-axis. So that's kind of like where in the world it is. So the bold red guy is Luch. So he starts out here, gets to his test station, does a little shift over of a degree or so, comes over here, does something interesting, and then comes and parks next to this green. These other colors are other geosatellites. Parks next to him, parks next to this one, and on and on and on. And like I said, right now, when I started this, I had a 3D loop going. That just happened to be right now. They're parked next to this guy who's kind of this reddish, rose-ish guy right up here.
Okay, so can you explain the chart one more time just so we can be totally clear on it? You got the time going left to right.
Right, the calendar's on the bottom.
And then your degree longitude going up, right? So
the y-axis is longitude. So think of it as where in the world. So initially
And you notice most of those other satellites are relatively straight lines because they're not traversing around the geobelt.
True. Yeah. So for the most of the time, typical comm satellites go park somewhere and they live there. They will get relocated. You see some of those here. You see sometimes these guys.
The green one at the top, I see he moves.
Yeah, it's not frequent though. You see here's one over here where they move from time to time. Satellite operators relocate their assets from time to time. So even, that's a good point, even right here at this level, moving 13 times in 5 years is pretty frequent.
Right.
You just don't see that.
So at what point did you notice this and start watching it?
When it was launched.
When it was launched.
Yeah, so there was a run-up in open source in the web in mid-September that talked about a secret Russian satellite was going to be launched. And I forget all the details, but it was enough that those of us, it was the very early days of ComSpOC, myself and some others, we looked at that and we said, we really want to watch this thing. And so we watched it from the time it injected a geo way over here on the left, and we've watched it ever since because we knew it would be interesting. And then...
at what point did you go, whoa, this is going all over the place? Is that when that big move right there?
Well, so this was a little interesting thing, and then they went over here. It turns out this kind of olive-colored guy and this kind of cyan-colored guy are Express satellites, Express AM22 and Express AM33, which are commercial but Russian commercial. So we have every reason to believe that those were cooperative engagements in the beginning of the mission.
Calibration or something?
Perhaps, yeah. And then they started drifting this way, coming west, and we watched them slow down and stop. And it turns out one of the first commercial guys they parked next to was an Intelsat. Like I said, they've parked next to almost every company out there. But this first one was Intelsat. And so when they parked there, we called Intelsat and said, you should be concerned about this. And
you have a new neighbor.
Yeah, and exactly. And that was, it caused a ripple because no one had told them at the time, and it was a new reality. Mm-hmm. And so since then, it's been the subject of a lot of attention. And so we watch it.
And that would come out in the public catalog, but it would be the delay to that for them being able to see it.
Yeah, but, well, yes, but even then, you have to put two and two together. So again, we had the open source reporting before the launch that it was some sort of secret satellite. Mm-hmm. And then there was information that actually was starting to report it was a SIGINT. And so based on that, we thought, the first guy they parked next to was not going to get a conjunction notification because there was not a conjunction.
Right.
But we said, if this thing really is a satellite that's trying to listen, you need to know this. Here's the other interesting part about this. Generally, they're not going after, let's say, U.S. DoD satellites. In fact, for most of the time you see on this graph, the location of U.S. DoD satellites has not been publicized. Very late in 2018, some of the policies were changed. Now, in the public catalog, you will see some of the comm satellites that the U.S. flies are in that catalog. But generally, they haven't parked next to them. So you said, well, what's the point then? If it's a secret satellite, military mission, why are they going after commercial guys? Well, turns out commercial satellites often carry leased comm for nation states. So, like the U.S. is one. In the U.S., our own U.S. assets, including all our ComSats, do not carry 100% of what our military needs. The government goes out and leases bandwidth on commercial satellites, and the U.S. is not alone in that. Our allies do the same thing. So, this guy going and parking next to commercial communication satellites there's a reason why they're doing it. Apparently.
Sure. So can you maybe go into some more of the details about some of the stuff you've seen?
So let's. I'm going to go through these. After a while, you will become numb, as we have become, because it's just another engagement. So this is. I
got a video. Cool.
Yeah. Now this is at the highest level. There it is going over in the beginning, and then so if you notice the clock.
Yep, it's going pretty fast.
The clock is going fast too.
Yep.
We wanted to.
Well, that's what I meant. The clock.
We wanted to get 4 years into a short video.
We don't have time for 4 years today.
It went over to the east to do some testing, came all the way over to the west, and then it's begun this series of engagements. And you see it's been slowly, every time they decide to move on to a new, I'll call it a target, they're moving to the east. So they're kind of walking the geobelt to the next opportunity they're interested in. And so you see we're getting up to this year. Pretty soon the video will end. They've been walking over this way, always pretty much within view of Western Russia. I don't know what that means. I don't know where their ground stations are or anything, but it seems like they're always within view of Western Russia.
Sure.
So that was very quick.
That was a pretty neat way to show it.
Yeah. And the blue guys are obviously just geosatellites. So I'm just going to very quickly go through them. This is the very first one. And everything I've done here is I've used the TLEs in the public catalog. So sometimes you see a little bit of discontinuity. That's okay.
So is this just the zoomed-in version of the report you had before?
Yes. This is the zoomed-in version for the period right here, December 2014 to February 2015. So Luch is the green line. Express AM22 is the pinkish line. And they're about a degree apart. And Luch comes over and parks next to this guy. We actually saw, as Luch was coming in.
Yeah, you can. If you point with your mouse, we can see it up there too.
Yeah, I'm trying to. There you go. As Luch was sliding in here and slotting, we saw the magenta guy do some very subtly change their behavior. And at the time, we said to ourselves, that looks like they knew Luch was coming, and they're working to make the Luch arrival smoother. It looked like a little bit of an orbital choreography as Luch arrived. It was quite interesting. And then, again, because these are public TLEs, there's a little bit of noise on the data, so to speak. And they stayed next to this guy. So over here, this is where they originally launched, did their initial on-orbit checkout, and then they parked next to this guy, did something. A few months later, they leave, all right? Then they go way over to about 93, 96 degrees. I forget exactly. Again, don't worry about this little discontinuity. That's the TLEs. this kind of bright green line is Express AM33. And see, they park next to it. And then they proceed to not try and stay there. And they let orbital mechanics push them slowly away, slowly away, slowly away, until they get to here and say, okay, time to move on. And then they go somewhere. This was the only time we've seen this. This was very weird. This sort of, I'm going to park next to this guy and then slowly back away. And not by firing the thrusters. Again, they let orbital mechanics do it. And that had us scratching our heads. Like, taken with the other 12 or 13 engagements, that looks weird. So given that it was Express AM33 and they had just demonstrated an apparent cooperation with Express AM22, one of the things we're left with is that they were, in the beginning of their mission, cooperatively testing how far away they could be to achieve what they were planning to do against all the other targets in the years to come. That's just a best guess, and these words sort of say that. If you capture it, I'm not going to brief the words. It's essentially what the words say. Then they went next to Intelsat. This is the one I said where here's the green line. Intelsat 901 is the light blue line, and it turns out there was Intelsat 7 right next to it is the dark blue line, and they parked right between them. And as they were slowing down, we saw the writing on the wall, and they stopped, and we called Intelsat and said, you guys should be concerned. And after a few months, they left and went somewhere else. Where they went, turned out this was another Intelsat. So now they're over at about 14 or 8, I can't even read that, whatever that is, 24 degrees west. So this is the furthest west they've ever been. Stayed there for a few months, and ever since then, they've been slowly walking back east. So here's another guy, another Intelsat, it turns out, because, if you look at the geopopulation of 400 to 500 satellites, Intelsat, by proportion, is the largest guy. They have something like 70 satellites they own. So just on a probability standpoint, throw a dart, you're more likely to hit an Intelsat than any others. And then you have to factor in, who leases comm, who does this, who does that. Here they park next to a Eutelsat. So again, they are absolutely an equal opportunity offender. We've seen them go after everybody. Stayed here for quite a while. This was about 9 months. Another Intelsat. Again, they're just walking their way along the geobelt. Here's a Pakistani satellite they parked next to, PakSat. And you see, so this one's about 4 months. So each time's a little bit different. This was a short engagement. This one was just several weeks. And this is actually, there's Turksat 4A and Turksat 3A. There's sort of the pinkish and the purplish lines, and Luch is the green guy who comes in. Was close enough to basically listen to both of their uplinks. And then they leave. ComSat, a Nigerian ComSat. So again, just reinforcing, they've gone after everybody. Again, if it really is a SIGINT and their behavior kind of looks like one, they're just going after whatever is a...
They have parked next to everybody.
Yeah, a reasonable target. Again, we've not seen them park next to a U.S. DoD asset, and there's probably reasons for that. Here's a Yasat, another Eutelsat, another Turksat, NSS. This one's quite interesting. So this was just late last year. For all of their engagements, they come and they park on one side of the target satellite, either to the west or to the east. This guy, they parked to one side, and partway through I'll call it the engagement, they switched sides. So that was kind of unusual. We said, what's up with that? Well, let's talk about this. So there was initially another object just west of this. So let me go back to the chart. So west is down on this plot. So
there you go.
What I'm saying is, so this is NSS 12, the black line. This is Luch coming in. Again, ignore this noise. It's just TLE uncertainty. There was initially another guy sitting here. We say, well, where is he? Well, it wasn't in the public catalog. Our data, our sensors could pick up, there's a geo sitting there. Well, that's interesting.
But you don't process untracked things not in the public catalog.
Right. By policy, we go out of our way to not maintain solutions on things that are not in the public catalog. But there was a guy we could see on the other side. So Luch was essentially between this unnamed guy and NSS 12. And then on December 5th is when the U.S. Air Force released orbital information for several of their DOD satellites. Again, I talked about that policy change. So one of those was a WGS 9. And it turns out The guy sitting over here was WGS-9. And then, so it was published on December 5th. On December 7th is when Luch initiated the sequence to hop to the other side of NSS-12. So I don't know that it's cause and effect. There's a relationship there. It could be happenstance, but given that it's the only time we've seen Luch do this, and it was 2 days after the U.S. published this, it seems like it's likely related. Now, you say, oh, so Russia didn't know it was there. I'd be willing to bet that Russia knew exactly that there was another satellite there, and they probably knew what it was. They've got their own ability to track stuff in space just like we do. I believe, my personal opinion is that since the U.S. had announced it had a satellite there, Russia felt like they wanted to maintain the appearances of being good space stewards, and they wanted to not be accused of parking next to a known U.S. DoD asset. That's my own personal speculation only, but again, this is the only time we've seen them do this. And then from February to now, they're parked next to Intelsat 33. So you see they've parked next to all these different operators, but always in a way that they're close enough to essentially listen in to the upload.
So what was the total?
I think we're up to 13.
13, okay, and across 5 years. That's a lot, but I'm not numb like you said I would be. still pretty interesting.
Yeah. Well, and again, it's we haven't taken the time to study. Is there anything that we can use to predict when they're going to move on? I don't know that there is anything like
What's
that.
What's the predicted lifespan of this satellite?
Oh, I don't know that I've seen that. I would guess it's probably at least 10 years, maybe more. It's got electric thrust and chemical thrust. Recently, we did a study of delta V expenditure by geos on orbit, and the highest, far and away, in 2018 was SJ-17, a Chinese satellite, and then there was a satellite that had done a kind of once every few years set of maneuvers, so it was high, and then the third highest was Luch, and then all the rest of the geos were down lower. And the point is, they do spend a lot of fuel doing what they do.
Right. But
I do know that they also have electric thrust engines. So not sure how long this will go on.
Got it.
We'll see.
All right. Well, thanks, Bob. That was pretty informative. We will come back later with some other reports of some other things that you've seen in the ComSpOC. And anything else you want to add on Luch at the end there?
No, that's it. Like I said, they've gone after all sorts of guys, and this is typically what you see. Look at that number. It's 60 kilometers, 50 kilometers. Notice
that's a very cool visual.
They're kind of aligned. And we'll be the first to know when we see them leave.
Great. Now, what do you use to do some of this deeper investigation? I know you used some proprietary tools up in the ComSpOC to do the tracking and everything. And then what do you do to do you've done a lot of further investigation of situations and things. What did you use?
Sometimes we're using SDK. There are two. We have a product out now called SOTA, Space Object Threat Assessment. Which wasn't always a product, but we've had it in our arsenal for a few years now. And we've used it a few times when Luch is on the move to help, in a predictive fashion, identify who we think they're going after. So when they're sitting, I'll call this still, when they're parked next to a guy.
And that just restarted if you're wondering what happened to the...
If you look at the bottom timeline, it's just looping 30 days.
Yep.
When they are drifting in between targets, this software allows us to identify potential candidates. And we've used that a few times while Luch is drifting to identify the likely new target. And you have to use it with your subject matter expertise and look at different things. But we've done that successfully several times. And that's one of the products that last fall, it actually became a product, SOTA.
So other people can do that analysis as well.
Absolutely.
Yep. Awesome. Well, thank you, Bob. Very interesting. We're not numb. It was even at 13, even cooler that you guys are able to watch it the whole time and see what he's up to. So thanks, Bob.
Sure.